Hello, and welcome to Connect and Collaborate, a podcast of the Colorado Business Roundtable brought to you by ACEC Colorado. I'm your on-air producer, Keenan Brew, and today I'm really excited to have in our guests from ACEC itself. So Heidi Gordon, welcome with ACEC, as well as Brad Doyle. Welcome to the show.
Thank you. Thanks for having us.
Yeah, very good to be here.
Absolutely. So I'm really excited because next week is Engineers Week. And before we get into the details of what that is, what it means, what's going on, and why you're doing it, I'd like to introduce both of you to our audience a little bit and let them get to know who you are and why you're involved. So Heidi, let's go ahead and start with you.
Sure. I'm the Deputy Director COO at ACEC Colorado. We're the State Association of Consulting Engineering Firms. We represent more than 250 firms with about 11,000 employees in the state. We're about the fourth largest component of the National American Council of Engineering Companies. And Brad is our president this year.
Wow. Well, welcome. I knew some of those facts. I didn't realize just exactly how big the Colorado branch was compared to the overall country size. And Brad, how about yourself?
So I am a project director with Atkins. Atkins is a global engineering company. Practice all types of engineering all across the nation and around the world, with about 200 people here in Denver, focused on delivery of projects for any number of clients in primarily the horizontal space, but we do some work in the vertical as well.
So when you're talking about the horizontal space and the vertical space, describe that to someone who's not in the engineering and construction industry like myself.
Okay, so the horizontal space is more of your roads, bridges, drainage infrastructure, and those type of stuff. So basically, that basic infrastructure that we rely on as everyday components of our lives. Whether we're driving or turning on the taps in our houses. The vertical space is more about buildings and everything that goes into the engineering of a building and making a building operate. The mechanical, electrical systems, and all that type of work.
Fascinating. All right. Today I learned. Could you describe a little bit about how you got into this field? What attracted to you from an early age or high school, college? How did you find out about it and what drew you in?
So I've been wondering that, trying to think back, how I got here. But growing up, I grew up on a farm, and it was always about farming. In that was always about problem solving. Because you didn't always necessarily have everything you needed, and so it was about just figuring things out and having to solve problems. At some point, as coming up through grade school and high school, developed a desire to do more with the maths and the sciences. And, so I started pursuing that, had a number of people, start talking to me about what engineering was and describing it, thought that it would be something I should consider doing. So kind of just kept going down that path until I ended up in engineering school.
Oh, that's amazing. It really makes sense with the farm background and coming up with, this is what we have, this is what we need. How can we put these pieces together? And so the problem solving skill definitely does translate over into engineering of larger projects. And how about you, Heidi?
I've worked for ACEC Colorado for about 5 years, and I've worked in association management for many years. So I've worked for architects, doctors, et cetera, other kinds of associations. But really enjoy my time with ACEC Colorado and engineering. It's just such a wide variety of career paths and choices, and so I really help the engineers with kind of spreading that message as far as filling the pipeline, which is what Colorado Engineers Week is all about, and the activities kind of around surrounding it to help encourage people to go into these engineering professions that they might have, interest in science or math or even art and not know that there's these options in consulting engineering.
Absolutely. So a lot of people really only find out about engineering if they know an engineer, or maybe there's other ways out there. But what have been some of the things you've been learning as you've been helping engineers and engineering companies tell their story and work on things like talent development and getting people interested? What are some of the things you've been learning?
I think that one of the things I've learned is that, as Brad kind of said, that somebody will start as an engineer in college, and then you have to kind of decide what path you want to take, whether it's the vertical or horizontal, and then the specialties within each of those areas. So whether it's civil engineering or structural engineering, we have mechanical, electrical, plumbing engineers, geologists, etc. So there's just so many different paths to choose from. And, we're not about advocating for one or the other, but just the profession of consulting engineering. We have a foundation actually that gives out scholarships every year to engineering students in the state. That's another pathway for us to kind of encourage people to, even if they're engineering majors, did you know about consulting engineering? And that's one of our messages to our scholarship winners each year.
Interesting. So as someone who generally has an idea about engineering, what is consulting engineering?
I'll let Brad to tell you a little bit about that.
Sure. So, as Heidi alluded, there's a lot of types of engineering in that. So consulting engineering in our profession, that it is where we are taking on projects, typically public works type of projects, or private type of projects where an owner is hiring us to come in and design a system for them, design a bridge, a road, or whatever. We are advising them in what is the best way to go about doing that, what's the best type of structure, setting up the performance requirements and all that. So consulting to them, advising them in what they needed, and then, carrying it through and developing that final product, delivering it to them. And then, coming back and watching it get built and advising them that, yes, this is the way we intended it to be done, and it's good and complete, and we're satisfied with how it turned out.
Excellent. So with all these different types of engineering and the specialty education and practice that goes into being really good at it, what were some of the milestones in your education and maybe early career path that led you down into this specialization, or how did you get to where you are today?
Okay. So, again, like I said earlier, I had a passion for the maths and sciences. Mm-hmm. That is, I guess, it's what drives you to continue down and to get into the profession. And so, through high school, kept pursuing higher levels of sciences and maths and some of the more challenging things, and getting into the calculuses and all that type of stuff. And then going on to college, went to school at the Colorado School of Mines. And, great education, great school, really set me up for success in a career. The funny thing about the math, and I think we're going to talk about this in a minute, the misperceptions, probably the highest level of math that I use today in my profession, I learned by the time I was in 9th or 10th grade in high school.
Wow. So
all those advanced maths and that, we've got great programs and great software that take care of a lot of that for us in my profession. Once upon a time, maybe you had to do more of that. It's still good to have the skills. And I think what it does is it teaches you the aptitude or the ability and that to be able to do the work. But really it's having the analytical mind, that you want to come at problem solving from a numbers approach. And try to think through a solution from that perspective. So after graduation from the School of Mines, went into construction management and inspection. So I got to go out and take a set of drawings and go out and work with a contractor to see that the work, or that the road was built in compliance with the drawings and was built according to the plans. And then just verifying that the quality was there, and that the work was being done so that it would be sustainable for many future generations, and that we wouldn't have any problems as a result of what was done. So, was able to do a lot of construction inspection and management, was able to do some design work, and, really didn't set a firm path for myself, was able just to kind of go by, what project opportunities, which has actually done a whole lot for me in that I've done a wide variety of types of projects, and that after some period of time, I ended up going more on the management side, actually starting to manage and run projects. And I think that's some of the most fun work that I get to do.
Absolutely. So one, congratulations. I know School of Mines is a tough school to get into, and it's a great education. And from my interactions with them, it seems like they have a lot of real life applicable industry partnerships. So the students there are actually learning what's going on in the industry and what they need to learn. I remember also my teachers describing, well, you're not always going to have a calculator in your pocket. You got to learn how to do this by hand. And it's interesting that you talk about you really use on the day-to-day basis what you learned in ninth grade, though I'm sure you've gone much farther beyond that. Though similar to what you learn on one project, knowing some advanced maths or that it's even possible, you probably don't have to write it down on paper by hand, but knowing that that process exists, you can use that as a tool and bring on other software programs to do that advanced calculations here for you. You mentioned a little bit, and I'm curious about some of the impacts that you both have seen about engineering in Colorado. So, as a daily driver, I use roads, but I rarely ever think about the engineering and design that goes into that. What would you guys describe as some of the biggest impacts that engineers have on the state of Colorado? And while I'm sure it's happening all over the country, specifically Colorado, how has that been a beneficial impact for us as a state?
I think Brad can get into some specific examples, but I know we have a whole social media campaign, #EverydayEngineering, that talks about that and talks about how really you can't do anything, whether it's drive or walk down the street, et cetera, without an engineering having been involved in whatever it is you're touching every day. So trying to educate the public about that. The small impacts, aside from, the larger impacts and the things that we all know as the engineering feats that Brad might touch a little bit more on. And so, things coming up like our Engineers Week, we have Denver's new building and fire code amendments and what building owners need to know about that. So that's going to be a panel of engineers who are going to discuss what those changes are and what those mean to a building owner. So even those small things are impacted by engineers and engineers understanding it because they're the ones who are helping the owners implement those code changes. So that alone. Do you have any examples of specific projects you want to touch on, or what you see as your big three maybe in the state?
Sure. Well, what I was going to talk about with this is, the impact that engineers have on things is that we're implementing it from a safety, quality, optimization type of perspective. So the impact that engineers have on a project, because there's any number of ways to be able to complete a project. And growing up on a farm, my dad could create a road just by taking a tractor out and driving across the field with a blade. What engineers do is they take that very basic, method of construction and that, and start figuring out ways to optimize it, so that really when we're coming up with the best solution, after taking analysis of various other things and that taking and finding the best way to do something, doing it in a manner that can provide the safety, so that on a highway, that the curves are right and that you can safely drive down this road at 65 mile an hour and not have to worry about, ending up in a ditch or something like that. So from a safety perspective, and then, quality in that, we're stewards of our owner's money. And, whether it's public or private, I work with a lot of taxpayer dollars, and really wanting to look out that we're giving them the best solution and that we've optimized it, and it's going to be done in a manner that can last for a long time. I've had a number of projects that I've been able to implement that on. I think my most impactful was up on Highway 82 between Glenwood and Aspen. I was able to work on a project called Snowmass Canyon, and it was at the time the second largest highway project going in the state, behind the T-Rex project here in Denver. I think we had a digit missing from our cost of our project compared to that one, but it was something that was badly needed from a safety perspective. It was a stretch of road that was very dangerous, and what we went in and did was expand the facility to help move cars more efficiently, but also do it in a much more safe manner with better curves and things like that to make it safe for the public.
Well, on behalf of the public driving, thank you very much for thinking about those curves, because a lot of people do drive very quickly, and it's good to stay on the road. So thank you for that impact. As far as impacting on people's lives, engineering is a great career, and you described a little bit about how you got into it, became aware of it. What are some of the ways nowadays that students can get involved in the beginning of this and becoming an engineer on that path?
I think a lot of the STEAM schools offer those opportunities to kind of see if that's an interest area and a path to start with. And there's, I think, a lot more, even than when I was growing up, that talks about kind of the science, technology, engineering, and math, or science, technology, engineering, and art and math, which I mean by STEM and STEAM. I always like to define those kind of opportunities for children, even in elementary school, middle school, to get involved. One thing that we're doing during Colorado Engineers Week is we're hosting a 3D screening. It's free to the public, of Dream Big, which is a film produced a few years ago with the National Society of Professional Engineers, American Society of Civil Engineers, and several other partners. And we're showing that during Engineers Week to try to encourage children of all ages to come and see all the amazing engineering all over the world. So again, giving those kind of opportunities to people to expose them. And we like to do that as, an outreach effort. So again, no cost to the public, and make those tickets free. That's, like one thing that we can do. Do you have other ideas, Brad, as far as how kids can find out more about the engineering path?
A lot of the schools have various, the programs, again, the science and math type of programs in that. My kids have been involved in, Science Olympiad and any number of other types of things. So you kind of immerse them in the stuff that leads up to engineering, the very fundamental and basics of that, so you reach out and look at those type of programs. I think they're great ways to explore what this is about, and again, back to problem solving. And then participate in things like what ACEC is doing with Engineers Week. The video that we're going to be showing, I think I've seen it. This will be my third time through it. My kids have seen it twice. I don't know they're up for a third though, Heidi.
They are. They will be.
But yeah, so it's an exciting career, and it's something that people should know that you can do a lot of things with it. When I think back to college, the first 2 or 3 years of my college career was pretty much all the same for all the types of engineers, and you started to specialize, in year 3 and 4 to try to figure out what you wanted to do with it. I graduated, my degree is geotechnical engineering, but I've done all my work in the civil space. So, it's just because you may set up and think you're going to end up doing this, it can go any number of ways. It's about learning those fundamentals to carry you.
Interesting. So there are specialization paths and programs, but there's also opportunities to be able to move and go into a couple different areas and apply things you've learned elsewhere to a different situation. That's really exciting. You just reminded me of Science Olympics. That was a great experience in high school, trying to make bridges, with popsicle sticks and hot glue, and how light can you make it and how heavy of weight can it support. That's fascinating that those projects lead to people to actually build real bridges if you go down the pathway and get there. One thing I wanted to ask you guys about were some of the misconceptions about becoming an engineer or being an engineer. Maybe people who aren't as familiar have a certain image of what it means to be an engineer or what engineers are like. What are some of the misconceptions you guys see on a daily basis, experience, and would like to set the record straight here today?
Myself, as an outsider, because I'm not an engineer, I'm a public relations person by background, is that I think people miss the kind of art part of that, or the creativity part of being an engineer, and the problem solving. It takes a lot of creative solutions, and a lot of people who really think about things outside of the box. And I think a lot of people have this idea that engineers have I'm going to say it, the pocket protector. See, Brad doesn't have one. and think about things in a very linear or like squared way. And I really would say what I've seen more of is, okay, we have a problem. How do we solve this? And thinking about things in a very creative solution and outside the box way.
Yeah, I would definitely agree with that. That engineers, we operate off of a whole lot of equations and formulas and things like that. And there's certain aspects of our job that from a safety perspective that kind of defines how we should do it. But those are best practices. Engineers, although have the ability to then take that and say, all right, this is a best practice, this is a guidance, and be able to do something with it to apply engineering logic, and to make decisions about, is that the right solution for this particular situation? And that's kind of the out of the box stuff, that we don't have to just follow all the rules all the time and get to apply some real logic to it. There is a lot of art in that aspects in it, the softer elements in our work. We want it to not only be functional and useful, but we also want it to be appealing and acceptable to the public in what we do. The biggest misconception is that we're all really, really good at math, and that we have to have those skills to get through all of our college curriculum and all those type of things. But it's not what you're going to be doing your entire life. You're not going to be deriving differential equations in your career unless you're building the software that's going to do that for everybody else to make their jobs a little bit easier. So, it's I guess it offers a variety of types of opportunities, and you can really do with it what you want. My current position, I'm more as a project manager, much more oriented towards, delivery of work and not the specifics itself. So kind of move through the technical side of it in my career and into project management, which then takes me in a lot of different areas. So I don't know, for me, it's a career that you can do almost anything you want with it. And for that, I would encourage people to join.
And I would just add, of all the engineers I've come across, which probably hundreds now, many of them are very good writers, which as a public relations person by background, that, something I wouldn't have expected, but I don't have to do a lot of editing to anything I send, including Brad. They're all very good writers. So again, that's that creativity, attention to detail, and making things are accurate. I know you do a lot of proposal writing as well, but that's something I don't think a lot of people consider. Like, hey, I'm a good writer. This might be a path for me. Because, that was never really something I ever thought about or thought was an option. And they all are all good at math. I've not met one bad at math.
there are some fundamental requirements. Yes. So, yes.
So let's clarify that.
So it is one of those things, kind of like the safety and compliance, the federal regulations of what's being done. There are those things that you have to do in order to be safe, and maybe there's a certain level of math you have to get to become an engineer, but that's not the day-to-day. You're also able to be creative and use that art or your human communication skills or human management skills. If you're working with a team of people trying to make a project happen on schedule, on budget, there's a lot besides math in order to get that done. Yeah. So thank you so much for letting us kind of challenge those misconceptions here. Really want to highlight again, I know you mentioned several of the events coming up next week with Engineers Week, but what are those events again, and where could the audience find out a little bit more on what's coming up?
Sure. On our website, acec-co.org, there'll be a link with some artwork to Colorado Engineers Week, and it's February 16th to 22nd. We have events for the public coming up on February 19th and 21st. On February 19th, here at the Colorado Business Roundtable, ICASA Media Studios, we'll be hosting that Denver's new building and fire code amendments, what owners need to know. And it's $10 to attend. That includes a reception. It is limited to 75 people, and I know tickets are going fast on that. So hopefully there's some still availability. And we really encourage anyone who's involved in building owners, management, development, et cetera, because these are some significant code and fire changes. We'll have expert panel of engineers talking about those codes from the technical perspective, as well as someone from City and County of Denver, an architect who kind of works in that department to talk about actually the next 15 years of changes that are on the horizon. The other event that I think anybody in the public, whether you're an adult or child, whomever, is our Dream Big 3D screening. And that's going to be at the University of Colorado, Denver South, down where the old Wildlife Experience Museum is. And tickets for that are free. There's a link off our website. We do have a limit of, I think, 225 tickets of those available. And we already have a number of those gone, but there's still availability, limit of 4 per person. And we have the concession stands open and everything like that during the event. We also have a special VIP reception beforehand. It's a fundraiser for our foundation. So again, you can find all those details at acec-co.org.
Excellent. Well, thank you so much for sharing your stories, where you've been, how you got here, and how other people can become engineers in the future and get involved next week with helping celebrate the achievements and really experiencing with 3D what's going on and how it works. So Heidi and Brad, thank you so much for coming in today.
Thank you.
Thank you.
And thank you for joining us on the Colorado Business Roundtables podcast, Connect and Collaborate, brought to you by ACEC Colorado.